These are the extra math questions from 2021, the short questions. Let's just go ahead and do them. Which of these is largest? If you draw the sine graph and the cos graph, essentially, you know the maximums are at 90 and 270, or for cos 0 and 180. Maximums, I guess, so actually 90. Basically, we're looking for the thing that's closest to that. Because these are entirely decreasing or increasing up to their maximum minimums, of course, we can just look for the thing that's closest to the maximum. So cos of 10 is 10 degrees away from its maximum, which is closer to sine of 115, which is 15 degrees away from its maximum. So that can't be the answer. 375 is also 15 away from its maximum, which is further than 10 is. 85 is only 5 away from its maximum, which means it must be closer to 1 than this is, so that's out. And cos of minus 20 is 20 away from its maximum, so therefore the answer is sine of 85 for our first question. B then, so if you watch my trinomial expansion video, you'll know how I'm going to do this. To get powers of x to the 3, I'm either going to choose one of those, and n minus 2 of those, or 0 of those, 3 of those, and n minus 3 of those. And I can use this formula for trinomial expansion, where n is just the n here, and all of these things have to add up to n, which in the two cases that I've said, they both will, right? 1 plus 1 plus n minus 2 is equal to n, and 0 plus 3 plus n minus 3 is also equal to n. So these are the two cases, and I just need to write these in some kind of intelligent way to get one of these answers out. So now this is just n choose 3, because it's of the correct form. So that's just n through choose 3, so it's something with an n choose 3 in it, which is not very helpful because that's the only one that doesn't. Now this is a bit more weird, but you can write it quite intelligently as 2 lots of this, because the 2's will just cancel and you get back to here. So it's 2 lots of n choose 2, and we'll get the answer of C here when we put them together. Quite a cool question. I like it. Trinomial expansion is very useful to know, I think, so maybe bear it in mind. C is an interesting question then. So we've got a circle, radius 1 down here. We've got a horizontal line that's going across it between 0 and 1. And it makes a quadrilateral. And it's the area of that quadrilateral that we're interested in, from the sides here to the intersections. And we're just looking at what plot, if you make this line higher and higher, what area you're going to sweep out, what plot is it going to be? Well, I know we're not really allowed to, but if you make the line 1 up, you actually just make a triangle. And you can easily work out the area of that triangle, right? It's the radius of the circle is 1, so it's 2 across, 1 up, half times 2 times 1 is 1. So the area at the finishing point is 1, which means we can get rid of this answer because it doesn't go down all the way to 1. But what's interesting about this one is it goes down, and so does this one here. So I decided to think about whether it makes any sense for the area to drop towards the end. And it actually kind of does, because if you put the line slightly lower than the top, you end up making a much wider, obviously, trapezium. And the small amount of area you lose based on dropping the height down ever so slightly is massively outweighed by the areas you gain by being allowed to go much wider. I know I can do this in a computer, so it's much easier. But if I just draw this shape over the top of this one, you'll see this tiny area you've lost here massively outweighed by the areas that you gain by making the shape a bit wider like this. And so therefore it makes a lot of sense that the area drops down towards the end like this. And so the answer is D. Question D then, so you start off at speed 1, which means it will of course take 1 second to travel the first unit. And then your speed halves. So when you reach x equals 1, when you reach the first unit, your speed goes down to 2 to the minus 1, which is a half. So therefore it takes 2 seconds to do the second unit, and you arrive at 2, in which case when you've arrived at 2, your speed is 2 to the minus 2, which is a quarter. So it takes 4 seconds to do the third unit, and so on, and so on, and so on. At this point, if you add up how long it's taken you, this is a nice little trick. Add up powers of 2 just gets you the next power of 2 minus 1. So that takes 63 seconds in total. Of course, I'm not going to get to the 7th unit because it takes 64 seconds to get there. And 64 plus 63 is bigger than 100. But I've gone 6 units and I've got 37 seconds left. So I'm going to make it into the 7th unit. I'm going to make it 37 over 64th of the way there, because that's how long it would take me to do the whole thing. And I have this long left only. So I think this is just the distance I'm going to travel. A nice little trick here. 64 times 6 is even, plus 37 is going to be odd. Because that only has powers of 2, it's not going to cancel down. And so therefore, without any further maths, I can just say the answer is going to be D for sure. E is a really tricky question. Really tricky. If there's no power of x of the 3, it's worth thinking about whether or not you can fiddle algebraically with this in some way to make it some kind of hidden quadratic or something like that, which would clearly make this problem much easier. It is possible in this case if you write it like this to start with, because of course we're not going to get a power of 3 out of this in terms of x. You're going to get x to the 4 minus 2kx squared, which is part of this stuff, and then just plus k, which is there. The stuff I'm missing is I'm missing a 2x, so I need to add that in. I'm missing a minus x squared, and I'm missing a minus 1. So I'll just tag all that stuff on the end. That's really hard to spot, but it's worth, again, if you don't see an x cubed term, the trick is probably some kind of really intelligent factorization of some kind to make it look a bit more like a quadratic, which is essentially what I'm doing here. Now, this object here, if you put it in a bracket, maybe like this, you'll notice that also factorizes to, of course, x minus 1 all squared. And now this is an incredible difference of two squares, right? It's this thing squared minus this thing squared. So I can put those together like this. And now instead of talking about when this thing has 4 solutions, I can talk about when this quadratic here, which ties up to this, and this quadratic here, each have 2 solutions. So, okay, well, when does this have solutions? When b squared minus 4ac is greater than 0. So let's test both of those things. So b is 1, so 1 squared, or minus 1 minus 1 squared is just 1. So test both of those things. You get k as this condition, or of course k during this one. I'm doing this very quickly, I know, but it's just algebra, is this condition here. So, okay, that's when we have 2 solutions from both. Now, the only problem is that we're not allowed, of course, to have any of those 4 solutions be equal to each other, because then actually you go down and have less solutions overall. So, for example, if the solutions of this were 1 and 2, and this were 2 and 3, then you'd only have 3 solutions in total, 1, 2, and 3. So what we have to do is check, okay, does this quadratic ever actually equal to this quadratic, and is that a solution? So let's just set this quadratic equal to this one. You get a solution that x is 1, but the thing is, that's fine, because x equals 1 isn't a solution to the problem. If you put in x equals 1 into this, you get this, which would have to imply that k is 1. And so I guess I should say, as long as k isn't 1, that means x can't be 1, which means these two quadratics aren't the same, and therefore you have 4 solutions. And I think that's all of the logic. So we can be between 3/4 and 1, because we're not allowed to be 1, and then over 1. Notice how this condition kind of completely pointless, because if you have to be over 3/4, then you have to be over minus 4/5. So yeah. F then, back to some slightly easier questions. We have the picture here, 3, 4, 0, 0. We have a circle going through it. And we have this other point B, where the distance to that is, the origin is 10. And then we have a distance, obviously, from 3, 4 to 0 of 5. And we're asking what potential coordinates could this be down here. Now, this is the diameter. It tells us AB, which means this is 90 degrees, which means this is a Pythagorean triangle. 5 squared plus 10 squared rooted is 5 root 5. So I need the distance between this point and this point to be 5 root 5. And that's how I decided to check which of these answers it is. I can also, of course, use the information that the distance between the origin and this point needs to be 10, which clearly gets rid of this 2 solutions here, because the distance between 4, 3, and 0 is 5, not 10, as it was here. So that can't be the answer. It breaks this rule. All of the others, a quick verification, shows follow the 10 rule. So now I need to check the 5 root 5 rule. So, okay, well, this one clearly actually does work. And that was the first one I looked at because it's the one that's nice. Because the distance from 3 to 8 is 11, and the distance from 4 to 6 is 2. 11 squared plus 2 squared is 125, rooted is 5 root 5. So this one works. And of course, this point will also work because the negatives don't matter. So then I had to check whether these ones don't work. And I think I can argue that all 3 of these don't work. Because if you look for the distance between 3, 4 and these points here, you end up with a surd, of course, within your surd. And of course, what you're aiming to get is the number 125. Like if you make this equal to this, which is root 125, you can cancel the roots, and you need the inside of this to be 125, which it's not if it's going to have roots in it. So this doesn't work. And for the same reason, this doesn't work, because it's basically the same thing. Now, this one could work if all the root 2's cancel. So you just check whether they do or not. And they don't, because this gives you like 30 root 2's, and this gives you minus 40 root 2's. So you've still got root 2's in there. And so that can't be the answer either. That can't create a distance of 125 or root 125. And so this must be the answer of D here. And sure. Which of these is the square of this thing here? Now, there's no way of verifying you haven't calculated it directly. So go ahead and square this if you want to. Otherwise, just notice that it's digits add up to 45, which means it's a multiple of 9. So you could write it in the form 9 times something, which means when you square it, that's going to be 9 squared times something squared, which is 9 times something else. So your new number must be a multiple of 9. And this is an if and only if condition. if your digits sum to a multiple of 9, you are a multiple of 9. So, and if you're a multiple of 9, your digits sum to a multiple of 9. So the answer that we're looking for has a digit sum that is a multiple of 9. So then we add up all the digits. Notice how all the digits are the same except for the middle one. So I added up all the digits that weren't the middle one and got 58. And the next multiple of 9 is 63, which means I need a 5, and this is the one that has the 5 in the middle, so therefore the answer is G. Well worth knowing this trick. It's come up in a couple of these papers, so well worth doing it. This hint basically gives away entirely how to do this question. You just try x is 1, y is 1 in here. You get f of 1 plus f of 1 equals 1 over f of 1 times 1, which is 1. That's 2f of 1 equals this, times across like this, divide by 2 and square root, and you get plus or minus 1 over root 2, but f of x is positive, so it's 1 over root 2. Good. Now, I thought about finding f of 2, because I could put 2 here, which would mean using a 2 and a 1, and you'd use a 2 as x and a 1 as y, and you could solve for f of 2 because you know f of 1, you've just found it. But then I was just like, well, why would I do that when I can just jump straight to 2021 using the exact same logic? Put in 2021 for this, put in y as 1, and you get this. And you know f of 1 is 1 over root 2. You can times everything by f of 2021. This is a quadratic. In f of 2021, replace it with y. Solve this quadratic. I just complete the square by halving this number for this, and then taking away the square. 2 root 2 squared is 8. Move that stuff over to the other side, square root. You get plus or minus this, which must be the plus, because again, y is f of something, and f of something is positive. Move that thing over, you get this. The answer is D, just there. I should mention as well, these function questions, if you've got some last minute time, UKMT Senior and Senior Kangaroo does a lot of function-y questions very much like this. So look out for those. Just open up a bunch of papers online and see if you can do any practice of these kind of questions, if that would help, because looks like it's something they could ask. I is a really nice question. Just going to follow lots of log laws here. So we're timesing two things in a log here, so we can instead add two separate logs. And we've also got sine to the power 4 and tan to the power 2. So you can bring those powers out to the front of the logs. Now, tan is sine over cos. And following another log law, division in here can be made into subtraction of two different logs. So we end up with this, which we could then, I guess, write as a bunch of different integrals. Well, combine the log signs, which is two different integrals with the numbers outside, obviously. And now if you just call the integral of log sine a and the integral of log cos b, or actually not a and b, because those are the limits that I've been completely ignoring. So I called them f and g. This is just 6f plus minus 2g equals 1, which is half of a simultaneous equation. So now we come up with the other half, which is this. Just bring the powers down, separate these out with a plus. You get this, and then you can just solve this by, I guess, timesing this by 3, and I don't care. Whatever. It's a simultaneous equation, just do it. You get f and g as this. This is essentially asking you what 4f plus 2g is. When you separate those out, it's just 4 log sine plus 4 log plus 2 log cos. And you just times those both by 2, add them together, and you get the answer of 4. Question J is absolutely brutal. So you've got a cubic that, notice, goes through the origin, and you want a straight line, a single straight line that's normal to it, like this one, except it's normal at two different points. So not like this, because this is only normal at one point, more like this, that's got a 90-degree angle here and also a 90-degree angle here. And then there's some condition for each k for which this actually happens. Now, of course, this is about normals. Let's differentiate. And firstly, what we want is, of course, we want this to be some value twice. Like, we want this cubic to have the same gradient in two different places. Let's just call that gradient a. Now, of course, it can do that. You can just add k divided by 3 and square root, and you get plus or minus the same thing. Now, all that really tells us is that this cubic has the same gradient symmetrically around the y-axis. So it's got some, if you just call this plus or minus b, at b it's got some gradient, and then at minus b it's also got that same gradient. Now, what we can also say about this cubic is that it's an odd function. It's symmetrical upside down, like around the y-axis. So basically, if you've got x is 1, you're down here. If you've got x is minus 1, you're at the same place, just upwards instead of downwards. Now, what that means, of course, is if you're two places where you have the same gradient, like b and minus b, that means your y-coordinates are also the same, just some plus and some minus. And what all that means is that this line here, which must go through both equal gradiented points, must go through the origin, because you've got two of the same triangles up and down either side here. So I've said all of that just to say that this line is of the form y equals mx for some gradient m. Now, what else do we need to say then? Well, we can actually now look for the intersections between this line and this curve by setting mx equal to the thing. And we can do that. We can divide by x because, of course, we know there's a solution x equals 0. We don't care about it, though. We care about these intersections here. And this has solutions, again, like this has solutions here and here. So there are two solutions to this. Bear in mind, we need both these solutions to actually exist. So at some point, we're going to have to check that k plus m is actually bigger than 0. But we at least definitely have two places where this line meets this curve. So that's good. Now, what else can we say? Well, we know stuff about the gradients of the line and the curve at those 2 points. We know they're negative reciprocals of each other. So the gradient of the curve is this. So the gradient of the line is m, which is minus 1 over this at that same point. So now we can put this point into here. Now x squared, of course, is just k plus m. So you can put that into here to make an equation just in m and k. So we're making a bit of progress here. You can work with that. You can cross multiply and stuff, and you end up with a quadratic in m. Now, this quadratic has to have a solution because we need m to exist, right? So this has to have a solution. So we need b squared minus 4ac to be greater or equal to 0. I don't care whether it has two solutions, but I do want it to have one. So, okay, well, that I can now do b squared minus 4c, and I find a condition for k. Amazing. Add 12 divided by 4, you get 3, so k is bigger or equal to root 3, which means you need to be either side of root 3. So bigger than root 3 or less than minus root 3. Cool. Now, that's actually one of the conditions. I didn't write it down, but k squared bigger or equal to 3, which is this one here. So maybe the answer is this, except now we have to go back to here and say, okay, well, maybe if you choose like k is minus a million, seems pretty likely that you're going to make this thing negative, which means the intersections that we were talking about here don't actually exist in the first place. So now we have to check that k plus m is actually positive. To do that, you have to go to this quadratic here and solve for m. So here's me just doing quadratic formula super fast. This is minus b. This is b squared minus, we've already done that bit. And then 2 times 3 is 6. You can factorize out 4 from this bracket, which rooted is a 2, and then the 2's all cancel with the 6 to make it 3. And you get this here, which means m plus k, which is actually what I'm interested in, is this thing here, because that's minus k over 3 plus a k makes 2/3 k. And I need this to be positive. Now, why have I ignored the negative thing here? Well, I actually don't care if m if m has two different solutions, plus and minus. I only want it to have at least one. And so therefore, I think I can just consider the positive one here. I don't really care about the minusy bit. I can just think about the positives. That's fine. So, okay, now I can just think, I need this to be positive. Now, okay, so we times by 3, obviously. I just want this to be positive. Now, if k is bigger than root 3, this is clearly positive. There's no problems, because positive plus a positive is bigger than 0. If k is a negative, I've got issues. So let's move the thing over, and now I can square both sides, except be super careful. If k is a negative, because I'm essentially testing this bound over here, if k is a negative, and I times both sides by 2k, for instance, this sign will flip. So I can do that as long as I flip this side. So square both sides, but I will flip the sign because I'm definitely timesing by a negative to do that. Of course, when I do this, I get this, which is garbage because this is definitely positive. And so therefore, if k is negative, there are actually no solutions because k plus m is negative, and I can't do anything with this. So therefore, this is the only condition that actually works. And so the answer is A, an absolutely incredibly brutal question that I assume was only written so that no one got 10 out of 10.